Hi everybody, in today's video we're going to build blue slime, just like this. Now this can be a seemingly complicated task, but we're going to break it down and make it simple and easy to digest. And so, by the end of the video, you'll have a blue slime of your own that you can fight.
Hi, my name is Michael. Join me as we build an epic Metroidvania game in Godot 4 using GD script. This is the Metroidvania Forge.
All right, so welcome. We're going to build our first enemy today, and this is going to be a self-contained enemy. This is not going to be the exact template that we're going to use moving forward, but I thought it was worth doing so that we could explore it. Some of you are going to want to stick with this and make several enemies in this style where they just are self-contained, okay? But it's going to get us kind of broken into this concept of how to make enemies and how to make them complex. So this is the slime, and he's pretty straightforward. You can see that we're using a few things like our damage and hazard areas and a new edge detector script that we'll build, which is just a raycast 2D with a little bit of extra functionality added onto it. And you can see that the slime has a few things. He obviously needs to move. We're building in the functionality that when he detects an edge, he'll turn. In addition, if I were to place this slime down here, and I'm going to put him up here so you can see he has gravity as well. Oh, shoot. Oh, no, I made him facing left. Okay. He will also turn when he hits a wall. Okay. So that's another piece of functionality that we're going to build in with this slime. We do have the option to make it so that we can start facing left or right, since he has no behavior other than walking and taking damage. And so you can see I can hit him and he'll take a little bit of damage. And he has 3 hit points, so 3 hits and he's dead. And there we go. I've just demonstrated all of the functionality that we need for this slime. Really, an enemy like this is pretty straightforward, but you're going to learn some new things today if this is your first time ever building something like an enemy. And like I said, it's going to get us prepped and ready for building more advanced enemies in the future. All right, so let's go ahead and get started. I'm going to try and streamline a few things in these later chapters of this series because I get kind of long-winded sometimes. If I start to skip out on details that you guys think I'm missing out on, then let me know and I'll slow back down. But chances are I'm just going to talk too much because that's how I am. But what I've done is I've uploaded a new zip file for Chapter 5 to the itch.io page for the Metroidvania Forge series. So go ahead and grab that. At the time of recording of this video, it only contains an icon and the slime assets that we're going to be using today. So go ahead and get those. You can see I've taken my icon and put it in the general icons folder. It's this little enemy icon here. And I've already created a folder for my enemies, and underneath that created a folder for my slime. And you can see here I've got the PNG, the sprite sheet, as well as some audio files that we'll use when we fight the slime. Okay, so there's one for death and one for hit. Okay, so make sure you get those in, and then we're ready to start building our slime. Okay, with that in place, I'm going to go ahead in my slime folder and create a new scene for our slime. And we'll give it a name. And we can go ahead and give this a script. I had built-in turned on. I was messing around. Okay, so this is going to be our slime script. And I didn't set this quite how I want to. I'm going to go ahead and just say create. Okay. Let's go ahead and change this slime though. So because this is going to be, an enemy that moves around, it would be best if we change this scene type to be a character body 2D. Okay. That way we have access to collision and stuff like that. And then of course we're going to want to change this, and we'll give it a class name. Slime. Okay. Clear out some of these little comments. And now that we've got this script here and attached, and we've got our slime set up, actually, let's do one more thing. Let's give it the icon. I love the icons. Okay, much better. So here's what we're going to do. We're going to set up the slime, and we're going to build the script, and we're going to try and do it all just in one video here. So hopefully it doesn't get too long. Obviously, there's some things that we know we need for a slime, right? As far as nodes in the scene tree, we need to have a sprite so that we can see him. He obviously needs a collision shape because this is built on a character body 2D. We've got that warning here telling us we need one. We're going to need an animation player to animate the sprite, and we'll need a couple things like maybe our hurt area and damage areas, those components that we built in our previous section where we built all the stuff for our player. So I'm going to go ahead and just start adding these in here. I'm going to add a collision shape. sprite 2D, animation player. That should not be a child of the sprite. Let's go ahead and add our hazard area. And let's see. Oh yeah, damage area, right? Okay. Very good, very good. So now what we can do, obviously we need to configure these. It's going to be handy to set up our sprite first. And I'm just going to drag the little slime in here. So this is a blue slime sprite. You can see he's got some walk animations and some, it's actually death and like take damage, kind of in the wrong order, but 6 by 3. So 6 horizontal frames, 3 vertical. Okay. So we've got our little sprite here. Let's go ahead now that we can see that and add our collision shape. And I'm going to use a capsule shape, primarily because I don't want him to get stuck on the ground when he's moving. Okay, and the capsule shape will help with that. But the capsule shapes tend to want to be a capsule standing up. So what we're going to do is we're going to actually rotate this. Hold Control to constrain the angle. And there we go. Now we've got a capsule shape that will hopefully work good for this guy. Make it a little bit smaller. Right, this way he won't get stuck on tiny little 1 pixel corners. That's a pretty common and annoying issue. What we can do for the hazard and damage areas is I'm going to go ahead and just add another. Obviously, these need a collision shape, right? I'm going to add one here to hazard area. And I'm just going to use a rectangle shape for this. And let's see. Yeah, let's make it a little bit bigger. I don't want to make them too punishing, though. And I'm going to go ahead and just duplicate this collision shape and drag it over here to the damage area. And there we go. So now if I change one, it'll change both. But they're nice, they're attached, they're set up. A little bit more that we need to do to configure these. Our hazard area should, we need to set up the collision, right? So it should be on looking on the player layer to deal damage to the player. So just turn all that off and turn on the mask for layer 5. And then our damage area, we need to turn on layer 6. He's on the enemy layer. So that way our player can damage him. Okay. And I want to go ahead and I actually kind of forgot about this. We've got an audio on our damage area. I should put the slime hit on there. Now that we've got this, I mean, this guy is kind of set up to do something. I mean, he's got a damage area and hazard area. So if I go to my playground and I just add a slime, like right here, then we should be able to see him and hit him and take damage from him, I guess, right? So let's try that out real quick. Oh. Okay, there we go. Kind of working. I've got 2 issues. One is let's go back to the slime. His collision, you can see I was running into him as if he were a wall. I don't want that to happen. Sometimes in games you might want that, but really for enemies, in my opinion, for a game like this, it's better to make it so that the player and the enemy don't collide unless it's explicitly required. And the reason why is because taking damage is going to cause knockback and things like that. And, in many games of this style, if you take damage, you can then run through the enemy. Okay, so we just don't want that kind of collision there. And that kind of removes some of the, I guess, I don't want to say bugs, but behavior that you might not want if he is collidable with the player, right? Like he can push him around and stuff like that. We don't always want that. So what we need to do is just on our slime here, let's go to our collision. He doesn't need to be on any layer. That's what's causing the collision with the player, because see, he's flagged as a ground. We don't need that. And of course, mask, we do need him to mask for the ground and for one-way platforms, okay? So really, nothing can collide with him, but he can collide with the ground, at least in reference to this, this character body 2D. Obviously, collision settings are different for the hazard and damage area. So I'm going to run those. Now it should work a little bit better. Yeah. That's kind of a funny sound for being hit. Sounds like a weird sonic trampoline or something. Okay, so there we go. That's set up. Obviously, the slime doesn't do anything. Now, this is a spot where I'll make a critical note. If you're looking at damage area and hazard area and you're saying, what the heck? Where did those come from? Those are custom nodes that we built in the previous chapter. So if you need to find out how we did that, you can go back, find that playlist, find the videos where we create those and build those assets. I think the next thing that would be good to configure, and I'm going to turn off my collision shape so I can see this better. We should animate our sprite so that that's all working. And we're going to have three animations. Okay, we're going to have like a standard walk animation, or I mean slither, whatever. I'm going to just call it walk. And then we'll have a stun and a death animation. Okay, so let's go ahead and create those. We'll start with the walk animation, and I love 0.1 seconds on my frame rate for these. 10 frames per second is, I think 12 is kind of like traditional animation. I tend to keep it around 10 and then adjust it as needed. And let's see, really all we need to animate is going to be our sprite 2D. So I'm just going to come in here to the walk and start with frame 0 and just key this in. So 1, dum, dum, doop, 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 doop. There we go. Okay, so you can see we've got this little walk animation. This, of course, should be looping. And then I'm going to drag this. You know, this is a new feature they've added in more recent versions of Godot. You can actually drag the timeline here for the duration, you know, but you could set it 0.6 seconds if you want to. Okay, so now let's play this with looping on. Okay, looks good. Now let's go ahead and create our next animation. So I'm going to duplicate this for let's do the stun next. And of course, for stun, we don't want looping on. So make sure it's not looping or ping pong, just regular. And then this animation is going to go from frame 12 to 16. So I'm going to set that first one to 12. I'm going to delete these, select my sprite. Let me drag the playhead so it sets it. There we go. Okay, so we're on frame 12. I'm just going to click this to get those in there. Okay. This animation is only 0.5 seconds in duration. Okay, so when he hits him, a little bit of goop's going to fly off, and then he'll kind of rebuild himself a little bit. And one more animation for the death. This one goes from frame 6 to 11. And so I think we're going to need to extend our timeline back up to 0.6. Again, make sure your looping is off. Since we duplicated the stun, it kept that for us. So let's go to Sprite 2D, set it to frame 6, and then we'll just key it. There we go. There's our death animation. He just basically turns into a little bit of goop and just flies off into the air. Okay. And of course, we'll cue free him so there won't be those pixels sitting there. Alternatively, there is like a blank frame at the end of this. So if for some reason you needed to, we could extend this by another 0.1 seconds, which is one reason why I like this frame rate when it works. It's pretty easy to pick. And then we could come in here and key one more frame in there, except I don't know what the last frame is. Let's just click through. Yeah, 17. Okay, that's the last frame. The last frame is blank. It happens to have an empty frame on the sprite sheet. So you could do that if you want to. That is not at all required. But there we go. We've got our animation set up. Looking good. Okay, so like I mentioned at the beginning, we're creating kind of the simplest version of an enemy that we possibly could. This is an enemy that's not really going to be super extensible. We're building a script that's tailored specifically to this enemy. And now there's not a huge problem with doing this, especially if you're doing a smaller game. In fact, if you're doing something like a game jam, doing all of your enemies this way is going to be quicker. If you're building like 4 enemies and you just build one script and then you make a copy of it for, next it's the skeleton and you just make a few modifications, that's perfectly fine. But obviously when you get to a game where you have dozens of enemies, like more than 10 or maybe even more than 5, at some point it's like, okay, I've got 24 scripts here. And then if you need to make a change to an enemy, you're going to have to go make a change to 24 scripts, right? If it's like, oh, I need to change how the hit points work or something like that, if you change a generic thing. I'm not worrying about that at this point because we will get to that later in this chapter. But right now, I just want to build this style of enemy so that those of you who've never done it before will see how it works. And the action of building this enemy is going to help inform us mentally of what we need to do with our state machine and our decision layer later on, right? Because we're going to be building in like the very rudimentary versions of the logic that this enemy needs. And so what are the things that a slime does? Well, a slime walks, he takes damage, and he dies, and that's it. I also want to make it so that this slime won't walk off of an edge. And we can turn this on and off to show you the difference, but I want to build that in. So he's kind of like a traditional Castlevania enemy that's just going to walk back and forth on, like if he's on a platform. So here in the playground, because I've set this slime right here where he is, I would expect that he would walk to the edge and then turn and walk back and just go back and forth, okay? He's not smart enough to recognize the player. Obviously, if the player is, bumps into him because he's either stupid or accidentally bumped into him while trying to dodge something else, he'll take damage. And that's really all these are. They're just a fun little obstacle. And, maybe they could do other things in the future, like reward experience points or drop items. We're not going to build that in this video, but in the future, we'll build that. Okay, so maybe they do that, but they're just general enemy fodder, really dumb and really basic. Let's go back into our slime and let's talk about this script and let's start building it out. We've set up all the rudimentary basics, but we're going to need some variables. I'm going to export a series of variables that are going to allow us to control things like the hit points of our slime, how fast he moves. One thing I didn't mention when we were looking at this, but if he can walk back and forth, we might want to choose a starting direction. So by default, he's facing to the right. So let's build in a variable so that we can flag him to start facing left. Okay, we can build that. And then I guess we just want to be able to export the sound effects that we're going to need. Okay, so let's go ahead and get those started. And I'm just going to type them in and you guys can follow along. Okay, so there we go. Those are the export variables that I think we need to set up. Now you can see we've got a float for our health, a move speed, 30, kind of slow. Face left on start, just a simple Boolean, and a death sound. We don't need to bring in the hit sound because we've already attached it to our damage area. Okay, so we already demoed that, right? He already makes a sound when he gets hit. We are going to need two other variables within the scope of this class. We're going to need a direction so we know which direction he's facing. We're also going to use the direction to kind of influence his speed a little bit. You'll see how we do that. But this is just a simple float that will be equal to 1, right? 1 is facing right, negative 1 is facing left. And I'm going to also include a tween. I'm going to call it move tween. And we're going to use this tween specifically for knockback, because I think that's something else, like if we're playing this, like when our player takes damage, he flies back. I think it would be good to make the enemy do the same so that not only can we knock him back to maybe get a little bit of space, but it might help prevent just being able to spam an enemy, right? Because eventually he'll be outside of your range. And so, I don't know, I think it adds a little bit to the game. And then lastly, as we're setting the script up, we're going to need reference to some of these things, right? Because we're going to have to do things like playback animations. Definitely need that. We'll need access to our sprite so we can flip it. Let's get a reference to both the hazard and damage area because we'll probably want to manipulate those. And I think we're going to need one other thing, but we'll get that. We haven't added it, so we'll add it when we need it. So I think that's a good start. Okay, so we've got a pretty good set of things here in our script. Okay, so let's get this. It is attached to my slime. I'm just going to run and make sure no errors pop up or anything like that. Yeah, there we go. Okay, so if you look at our slime, here are the export variables we set up. Let's add the death sound. And then there's a face left on start, move speed, and health. Perfect. Okay, so I'm going to build this. Let's go here. I'm not going to use process, but I do want to use physics process. So I'm going to just change this real quick. And then let's talk about how this is going to work. So generally with this guy, because he's really simple, we're just going to continually move him until he meets a condition where he needs to change direction, whether that be because he bumps into a wall or because he finds an edge. And we'll get to the edge detection momentarily because we don't have that built in yet, right? We don't even have anything in our scene tree to make that easy to do. But I want to start with just some basic movement so we can get that hooked up. And that will include playing back our walk animation, which let's go ahead and just play that in our ready function. So I'm going to just grab the animation player and play the walk animation. Now we could set this as the animation that plays by default, but whatever. I don't mind setting it in script. And then let's talk about the physics process. This is going to be really simple. Because this is a character body 2D, we can use the move and slide function to make him move. We obviously just need to set the velocity of the character body so that it has a speed and direction to move. So let's start with the X velocity. So velocity.x. All we're going to do is just set this equal to the direction multiplied by the move speed. Now, we wouldn't have to do this every frame, but later on, it's going to be important that we do. Alternatively, if we were just going to let him move and never change, we could put this like in the ready function or something like that. Okay. But let's just do this and run it. So he should move to the right. Yeah, there he goes. But no gravity just yet. He's a flying slime, apparently. That's why he's blue. So let's go ahead and handle the gravity. Now, the way I want to handle gravity is I'm not going to manipulate the y value of the velocity. Instead, I'm going to add, and I'm going to use this. This is actually the first time I've used this handy little function. It's called get gravity. And let's look at get gravity real quick. You can see that it returns a vector 2. So this function returns the gravity vector computed on all sources that can affect the body, including all gravity overrides from area 2D nodes and the global world gravity. So in this sense, when we haven't done anything except we obviously have gravity set in our project settings, right? If we go to project settings and let's look for gravity, there's going to be a 2D gravity, which is at 980 pixels per second squared. So it's just going to get 980, okay? On the y-axis. Now you could change the axis of the gravity, but the reason why we're not going to do that, but the reason why this get gravity is cool is because you can manipulate the world gravity and suddenly you can see that this is a vector 2. So if the gravity starts rotating, then theoretically this would cause your enemy to fall in a different direction. So that's just a little hint. If you're building something weird where you're going to have like odd gravity or like a Mario Galaxy globe thing that they're running around, you might get a lot of mileage out of this get gravity function and manipulating that gravity globally. Okay, that's just a thought. But anyways, so that I mean, that's a long explanation of saying that's basically the same as saying dot y plus equals 980 or something like that, right? But there we go. So now we've got gravity. So if we run this again, we're going to see our slime should fall. Boink. Wow. He falled really fast. The reason is because let's look at this again. This get gravity does not take the delta into consideration, right? So that gravity is like if we go back to our project settings, you see how this is expressed in pixels per second squared. So obviously our physics process is happening faster than once per second. So we just multiply this by the delta and that'll fix that fall. He should look a lot better now. Pew, much better. Okay, there we go. Bumped into a wall, but we'll get that next. Okay, but hopefully this movement code makes sense. I mean, it's ultra simple. And to be fair, a lot of our advanced enemies are going to use something very similar to this. It's just all of the stuff around this and the decision making that's going to move out to other scripts. So how are we going to handle bumping into walls? Thankfully, since this is a collision body 2D, we've got a handy little thing that we can use where we can say if, what is it, is on, you see we've got on ceiling, on floor, and on wall. So I'm going to say if is on wall, then we're going to change direction. And let's actually make a function for this because we're going to want it later on. Okay. And what we're going to do is we're going to make it so that this function expects us to tell it which direction to change to. And so in this case, all we need to do is take our direction and multiply it by -1. Or alternatively, we could type in negative direction. Okay. So let's go ahead and create this function and we'll just build it right here. And of course, we're not going to say negative dir right here, but we're going to say new dir, which is a float. Now, the most basic thing we need to do is just say direction equals new direction. Okay. You're probably wondering, like, that's one line of code. We could have put that right there. We're going to end up using this for a few other things, though. That's why it's nice to abstract it right now so that it's just ready to add on to later. So if we run this, the slime should... Okay, hold on. He's too slow. I like that speed. Obviously, I set it that way. Let's increase this a whole lot. Let's make it move at 150 pixels per second. Pew. Oh, he's a super fast little slime guy. Holy moly. Okay, so now he's changing direction, or his movement is changing direction. The sprite is not. Okay, so now you're seeing why we want to split this out. Because there's not only are there other places where we might call change direction, but it's nice to keep this functionality kind of just bundled up. So really what we need to do is we just need to check our direction. If our direction is less than 0, then we need to take our sprite. What is it called? Sprite 2D? Yeah, there we go. And set the flip horizontal. In this case, it's true, because if the direction is negative, he's moving left. Is that the right? Well, my camera's backwards. Left. L if it's greater than 0. I'm intentionally ignoring 0 because I don't want to change it if it ever hits 0. And we call this, okay? Because that means he stopped moving, but it doesn't mean he changed direction. Okay, so there we go. Now we should be able to see our little sprite. Whee! There we go. He changes direction. Perfect. Now let's add in the condition where maybe we want him to stay on the platform. Okay, so let's go ahead and introduce one more thing there. Obviously, we don't really have a way to detect that because we could check for like here we said if he's on the wall, we could say if he's not on the floor, well, then he left the platform. And we don't want to do that. By the time he's off the floor, he's falling. It's not going to work. So we're going to do something with a raycast. Okay, remember how in the introduction to this chapter, I talked about the concept of compositional design. We're using that here with our hazard areas, our damage areas. Godot is built around compositional kind of architecture, right? And so it's nice to kind of lean into that. And so what we're going to do is we're not going to simply add a raycast 2D, but we're going to create a new type of raycast 2D that we can reuse. And so I'm going to go to my enemies folder and I'm going to create a new folder for scripts. These are going to be all the general modular scripts that we need for enemies. So even though this guy is basic, we might as well build this new type of thing here because we're going to use it in the future. So I'm going to make a new script in this folder and I'm going to call it edge detector. Okay. Now this should extend a raycast 2D node because that's what we want it to build off of. And I love that it set this up. I don't love the comments. Okay, so what is this going to do? Obviously, this is a raycast. And what we're going to do is we're going to place it in front of the enemy so that as he's walking, we can determine if he's still on the ground or if he's about to leave the edge. Because if we put this in front of the enemy, then let's say that this detects collision with the ground. As soon as it does not detect any collision, we know that he's reached the edge of a platform. And then we can send a signal and our enemy can pick it up and say, oh, I just found the edge. And then we can write code to help them determine what to do. In this case, just change direction, right? But for others, it might be jump or, I don't know, something, stop, right? There could be other things that you do. But what we're going to use this for is that. And so it's going to be pretty straightforward. But as I mentioned, we want to do a signal. I don't want a space there. I wanted to return. Let's just have this signal be called edge detected so that it's very clear what it does. And then I want to just add one variable. This is just going to help us keep track. And by default, we'll just say this is true. I don't know, right? So a Boolean to know if we're colliding. Because we're going to be using this script in a way where we're always dragging it in, one thing that we've got with these hazard and damage areas is we have to go set the collision layers manually every time we add them. And that's okay because they're not the same for every damage area or hazard area. But in the case of this new edge detection, we always do want to check for the floor layers. So I'm just going to go ahead and code that setting here into our ready function. So what I'm going to do is I'm going to say set collision mask value, and we're going to pick layer 1 and set it to true. And we're also going to pick layer 2, right? Because layer 1, I mean, I've got my hazard area selected, but you can see collision layer 1 is our ground and 2 is our one-way platform. So those are the two things that they can stand on and walk on. Okay, so we've got that set, and now we don't have to worry about setting that, because obviously when we drag this in, we don't want to have to set that in the inspector. If we forget, then our edge detection will be broken, and we'll wonder what's going on. Again, we're not going to do anything in process. We'll do it in physics process, because this is something that needs to, right, it's only going to update when the physics updates anyways. So we're just going to write the code, like how is this going to work? So we're going to just say, we're going to make a variable here to check, and this is going to be our is colliding Boolean, and this will equal, and we actually have a function, right, is colliding. I'm just going to do it here so that we don't have to call this function more than once. I don't know if it's very expensive to call is colliding, but I'm just going to call it at the beginning and store it. And then we're going to just check if, see this value up here, colliding, I'm going to compare that to what this is, because I only want to respond when it changes. So if colliding does not equal this new is colliding that we're checking, okay, so if those are different, then we know something's changed. Either he was on the ground and now this doesn't see it, or the alternative. Then what we'll do is we'll set our colliding value equal to this is colliding. And then we're going to emit the signal if we're not. So if this new value is false, right? So if not colliding, right? That means this raycast is not detecting the ground. Then we'll emit our signal. Okay, so that's pretty much it. That's pretty much all that this needs to do to be able to detect when it's on an edge or not. Okay, and this might seem a little convoluted. It's just so that, like, let's take the example where our slime, and in fact, to do this, I'm going to go ahead and save this, and let's add an edge detector to our slime. Okay, I'm going to come in here. Okay, so, and I want to, let's get our animation onto the walk animation. Okay. So as I mentioned, we want this edge detector to be kind of at the front of him. And it might be nice to turn on our collision shape so we can see where that is. You can determine how far off the edge he needs to be, but I'm just going to drag it roughly over here, which if we look at the transform, it's at 7 on the x-axis. Okay. It doesn't need to be -1, but it would be good that this is above the collision shape. And since this collision shape pops down 1 pixel, then having the y coordinate on 0 for this is fine. Now we don't need this to cast very far down either. Let's go ahead and set our target position to just like 8 pixels, okay, on the y. You see how this is going to work, right? The slime is walking forward. Let's come over here. Slime's walking forward, and this is true. And then if we look back at our code, because this is true and it's still colliding, nothing's going to happen, right? Go back to our playground. The moment this goes to false, right, because he went off the edge, then these no longer match. So we're going to store the new value and then we'll emit edge detected. Okay. But this means it prevents doing anything in the interim. Now, there could also be a potential where for some reason you get is colliding false twice in a row because of maybe some other reason. This is going to help prevent that. So like, you know, if we're, where am I? If we're here and for some reason he flips, but it doesn't update the physics for that for 1 frame, it's not going to flip him back the other direction. Like, right? We've already kind of set something. We've already checked and seen the false condition. So if it's false twice in a row, it's going to be like, oh, I already did false. Just ignore that. Is that making sense? That's kind of why we're storing it and checking it this way. Okay. So let's see. Let's go back to our slime. This is pretty much set up. I'm going to go ahead and turn on visible collision shapes so that we can see this happening. I don't want to see the collision area though. I just want to see this raycast. We haven't hooked it up yet though. So let's just go ahead and run this and see what it looks like. Oh man, that was too fast. I got to slow my slime back down, don't I? Move speed back to 30. Okay, so, oh no, go to my playground. I also started him on the edge. Let's start him in the middle. Jeez, figure it out, Mike. Colliding, not colliding. Okay, so at that moment it became not colliding. We need him to turn around, right? When it's red, it means he is colliding. So let's go into our script and we're on our slime here. Okay, so we've got a slime script up to the top. Let's just get a reference to our edge detector. And now we can connect to this, right? Okay, so what we're going to do is we're going to utilize that signal. So just in our ready function, we're going to say edge detector dot on edge detected. There it is. Okay, so we're going to connect to that signal and make a new on edge detected function. Okay, let's go back down to the bottom. Now this is going to be really simple. I'm only going to add one condition in here just to be safe. I'm going to say if is on floor. I only want to run this when we're on the floor. So if for some reason this happens while he's in the air, like maybe he spawns above the ground, he's not going to turn, he's going to fall. Okay, does that make sense? So if he's on the floor, then we'll call change direction. And we can just pass in negative dir. Okay? Muy bien. Same thing as what we're doing on here. With this in place, boink, he flips. Now we have one last problem we need to solve. You see how this guy is on the end? You could stick that in the middle, and that might be okay for some enemies, but I'd like an easy way to be able to move this edge detector to the opposite side. And there's a lot of ways we could do this. What I'm going to do is I'm going to go back into the edge detector script, actually, and we're going to introduce a little function in here And we're just going to say direction changed. Okay. Did I spell that right? And what we need is a new direction. And the reason I'm doing this here is because I don't want to have to write this function to flip this in other scripts. I just want it to be simple. Okay. So when we pass in a new direction, we're going to just do a check. So we're going to say if new direction is less than 0 and our position dot x is greater than 0. So what this means is let's look at our slime. So if we flipped and we're facing a negative direction, and then our arrow though is on a positive direction, right? Meaning the x coordinate is, what do I have selected? Oh yeah, right there, 7. Okay. Then we know that, hey, I'm walking the other way, so I'm going to want to move it that way. And so what we're going to do is we're just going to assume that wherever the user has placed this coordinate, wherever the developer, us, wherever we've placed this, that x coordinate should just be negative. So I'm going to go back to my script, and then we can just say position dot x, let's see, times equals -1. Okay, so that's just going to, but we can also add one other condition in here, or, because obviously it could be the opposite, right? It could be the other way around. So we can say if our new direction is greater than 0 and our position dot x is less than 0. I think that's right. Okay. Now, if it happens to be that the position is at 0, then nothing will happen. But this way, it'll flip it. And all we need to do now is go back to our slime. And in our change direction, obviously we've done this here. Let's just go ahead and do this. We're going to get our edge detector dot direction changed, and we can just pass in the direction. Okay. So now as we watch this, we should see that little arrow flip, and it'll just go back and forth. Easy peasy, just like that. Okay. Cool. So now our edge detector can tell the enemy when he got to the edge. We're obviously responding appropriately, but we're also building in some functionality to make it easy to move that guy back and forth. Okay, cool. We have edge detection. Congratulations. Now, one thing that we can do real quick that's related to all of this direction stuff that we've been doing is, remember, we have this face left on start. And so what we will do is, this is actually going to be really simple. I'm just going to go ahead and come into our ready function, and we're going to just say change direction. And we're going to say -1.0 if face left on start, else 1.0. This is a kind of a nice little shorthand if or else statement that we can plug in here. So we're going to get left or right. Okay. So then if I look at our slime, we can come in here and just click face left on start. So even though it's facing right, when we run it, there we go. He's facing left. Okay. Easy peasy. Okay. Believe it or not, we've built most of what we need. Obviously there's a couple things that we haven't hooked up, and really I'm thinking about this damage area. We can hit the slime, but it doesn't actually do anything to the slime, right? It plays the sound effect. Okay. If we go and test it. Oh, it's not even playing the sound effect right now. What on happened? Oh, there it goes. Look at that. He's too short for me to hit. Okay, so let's go ahead and make him easier to hit. Damage area. You know what I'm gonna have to do? I'm gonna need to separate this guy from the other one. I don't want it to change the other one. So I'm gonna say make unique. Turn both these on. Let's turn the hazard area collision red. I didn't think that one through, did I? And then we're going to go to the damage area, and I'm going to drop it below the hazard area. So that one's on top, and drag this up. Okay, there. Now we should be able to hit him. There goes my notification about something. Okay, we can hit him, but he don't die. I mean, he should only take 3 hits to destroy, right? So I'm going to go ahead and close this. And I'm going to turn off my debug because that's annoying. Don't really need it anymore. I think we can see what we're looking for. So let's head into our slime script. And we've already got a reference to our damage area. We just need to connect. Let's go damage area dot on, what is it? Is it damage taken? Damage taken dot connect. And we'll just make a new function for this. Okay. Okay, this on damage taken signal actually emits the attack area, right? The one that hit it, which is important. We'll need that. But really all we need to do is we can start by saying health minus equals, and then we'll just get the attack area's damage value. Okay. We're going to want to do some sort of knockback, but we'll come back to that. Okay. And then we're going to do one of two things. We're going to check. So if our health is greater than 0, then we know he just was stunned, right? Else that means he was dead. Okay. So what we can do is I'm just going to go ahead and add something here just to get rid of the warning on this. So we're going to say audio. So if he dies, then we'll just play the death sound. What am I doing? Play spatial audio or play spatial sound. And then we're going to use our death sound and at this global position. Okay. But really those are just the two things. Taking some damage versus dying from taking damage. So what we'll do here is all we really need to do is play a stun animation. Okay. And then down here, obviously, we're going to grab our animation player and we'll play the death animation. And we're going to play the audio. And one thing I want to do here, well, here, let's do this. There's some flaws. So we're going to have to work on this a little bit, but let's just test what we've got so far. We should see him do an animation, but now his animations are broken, but that's okay. He should die after this hit. Okay, cool. But you see how we haven't Q-freed him. He's still moving. And in fact, there's one thing that I want to do. Even before he finishes his death animation, as soon as you hit him and he dies, I don't want you to be able to take damage by walking into him, even though he's still, because he's still going to be there for half a second while it plays that death animation. So I'm actually going to get rid of the hazard area and the damage area right here. So I'm going to say damage area dot Q free, not Q redraw, Q free and hazard area dot Q free. Okay. Now we do need to Q free everything, but we're going to handle that in a different way. And I'll show you that in a second. So now we should at least not take damage when he dies. See, and I could run through him while he was playing that animation, which I like. It's a little bit goofy without the knockback because it just keeps moving. He doesn't even stop moving, right? But let's first handle the animations not playing or, just getting stuck. So what we're going to do is we're going to come up here to, again, to our ready function. And I'm going to do it up here with the animation player so that it makes sense. Animation player dot, and then there's a signal for animation finished. And we'll just connect to that. And we'll make this new function. Lots of little signals, lots of little things. We're getting close to 100 lines of code. Not too bad though. Okay, so when an animation finishes, this signal provides us the animation name. So just plug that in there. That's a string. We're just going to do one of two things because really we've got 3 animations, but the walk animation is looping, so it never finishes. It never has a finish signal. Okay, but the stun and the death will. So we'll do a check. So if a anim name equals sting, stung, stun. Okay, if it's stun, then we just need to play the walk animation when we're done. Animation player dot play walk. Okay, pretty straightforward, right? Let's go ahead and test that. Cool, back to walking. Then the other thing we need to do is elif, I guess, if anim name equals death. Technically, we don't even need that. We could just make it an else. If we had other animations, we might not want to do this, right? But if not, then we can just Q-free the whole thing. So even though we've Q-freed these guys up here, we're going to Q-free the whole enemy once this animation has finished. Now, if you're playing sounds from within an enemy, it's going to cut off those sound effects if they're still playing at that time. That's why, we built this, one reason why we built this global audio system, so that sound effect is separate from the enemy himself. Okay, so now, that's not going to be super noticeable because he's not visible at that point, but he's Q-freed, okay? Like if we were to check our remote scene, we're not going to find, there's no slime, okay? Actually, he would be under the playground, but yeah, no slime in there. All right. Okay, so there's one last thing that we want to do, I guess, before we can officially wrap this up, and that's add this knockback. Okay, so the knockback, we're going to make a new function. And in fact, we'll just call it knockback, just like that. Okay, we're going to need our attack area's position to be able to calculate this. So Let's pass in the global position. Okay. Okay, so let's create this function here. And this is it. I mean, after we've done this, we're done. And we've got a fully functioning slime. Okay, so this, of course, isn't that there. What we're going to call this is, I'm just going to call it a position. It's a vector 2. So the reason why we're going to do this here is, let me explain briefly. So when we hit the enemy, we want him to get knocked back. And so we need to devise some way where we can change his velocity. But we don't need him to change direction. He's not going to face the other way and go, right? If he's walking to the right and you hit him, he's not going to just face left. He's going to keep coming at you and walking in the same direction. So we don't want to do that. But what I've devised is a simple solution where we'll use this direction variable, and we're actually going to manipulate this value here, okay? But we're not going to call the change direction. So in some places, like when we hit a wall, or when we change direction, or let's see, where is it? When we edge detect, okay, we'll call change direction. But in this case, we're not going to. So knockback, we're not going to change direction. Instead, what we're going to do is we're going to take that direction value and we're going to tween it. Okay, so we're going to tween it from a value opposite of its current direction. So if he's walking in the direction 1, then we're going to tween it from -1 back to 1. So he'll go backwards for a second and then slowly move back forward by the end of the tween. Okay, so that's the purpose for the tween in this. There are a lot of other ways you could do this. And in fact, the tween might introduce buggy behavior if you get a really complicated enemy. So we may not keep this style of knockback in the future, but for this guy, I think it's pretty adept way to do it. So I'm going to just create a couple variables. We're going to need a from value, which is a float. And this is going to equal our direction. And then we need a to value, which is a float, which is going to equal our direction as well. We're going to manipulate the from though. So here's what we'll do. We'll say if our attack position X is less than our global position dot X, then what we know is that it's like to the left. No, then we know, yeah, the person that attacked us was to the left, so we need to move to the right. So what we're going to do is we're going to take our from direction and we're going to add 2 more to that. Now, this doesn't matter which direction he's currently moving. It means if he's already moving one direction and you hit him from behind, it's going to actually send him a little bit farther forward than if he's facing you and you hit him. And that there's other ways you could code this so it doesn't do that, but I kind of like that effect. So we're either going to add 2 or subtract 2 from the from, okay? So it's going to start at either 1 or -1 and become either, it's going to become like 3 or 1 or -1 or -3, something like that, okay? Now, the next thing we need to do is we just need to check. If we have a tween already, then we need to just kill it because we can only tween once on it, and we don't want to be building multiple tweens and stacking these because that could get really weird. So we're just going to keep, that's why we have a move tween up here so that we can keep track of it and make sure we don't overlap. Okay, so we're going to move tween dot kill, and we're going to set our direction equal to our from direction that we just calculated, right? So we started at our normal direction, we manipulated it, and now down here we're going to set it. If our direction was 1 and now we're going -1, right, then he's going to be moving the opposite direction. And then, like I mentioned, we're going to tween it back to this original direction, which is the 2, because we stored it there as well. Okay, so if this was 1, if the direction was 1, the from becomes -1, but 2 will stay +1. Okay, so let's go ahead and set up our tween. So we're going to take our move tween, and we need to create a new tween for this. So move tween equals create tween. Really, we only need to do one thing, but we're going to adjust it so that it's a little bit nicer. But we're going to do, let's see, move tween dot tween property, and the object we're going to tween is ourself. We're going to tween. We can actually tween our variables, so we can tween dir, that direction value here, and then we're going to tween it to the 2 value. That's our final value, right? So it's going, we're setting the from value right here, and then it's going to the 2, and then we just need to give it a duration. I'm going to go 0.3 seconds. Okay, you could export a value for that if you want. I don't see a whole lot of benefit to that. That should be enough. Let's try this out. Let's see if it works. Okay, so if he's facing me and I hit him, hey, there we go. If he's facing away, you see how he kind of moved a little bit faster? Kind of fun. Now I don't know if you saw that. It's a little bit gross when he dies. The slime keeps moving. That's kind of weird. So let's build in one little condition here. And after we've set the direction right here, let's just do a check. If health is less than or equal to 0, then we know that he is dead. We're going to set our 2 equal to 0. Okay, so that means that he's going to fly back and then just stop, as opposed to, returning to his original movement direction. So this should look a little bit nicer. There we go. Ta-da! We built an enemy. Okay, I hope you guys learned something from this. We've done a lot of the same kinds of things we've done before. We're just using them in different ways, right? That's the beauty of programming and the beauty of Godot. In the process of building this enemy, though, we've also what have we done? We've built the new edge detector script, which is going to become one of the standard sensors that we use for our enemies in the future. And we've explored how we can use the hazard and damage areas on an enemy as well. And of course, we're looking at this script. I mean, this isn't too bad, right? If you just made a few enemies like this, there's no harm in creating a copy of this and making it be skeleton and adding a little bit of logic in there. Okay. So really, you could take this and just continue to move forward. But if you get to really more advanced enemies or high quantity of enemies, then at some point, this kind of a system is going to crumble under its own weight. Like when you come back and you need to make sweeping changes that affect all the enemies in the game, then that could get really hard. And obviously we could use extendability. We could have built an enemy class that had some of this stuff built in, like the health and the move speed and maybe the on damage taken and stuff like that. We could have built that in and then extended from that. And so then the slime just adds its own functionality. Like, I don't know what the slime would add in this case, but maybe you just have different types of enemies like flying and walking enemies, and then you just tweak them with the export values. That's an option too, right? Because we could technically make a copy of this slime and just change his health and his move speed. And now he's a different slime, right? I mean, maybe his sprite as well, so he looks a little bit different. And then it's using the same script. So, I mean, that is an option, okay? There's lots of options, I guess, is what I'm getting at. And what we're looking at here is just one option that's a little bit easier, a little bit quicker to get going, but also some drawbacks as far as flexibility and modularity in the future, okay? So if you've got questions about any part of this slime and how it works, go ahead and drop those in the comment section below. Or, if you have an idea, share it. I'd like to hear what you guys are thinking. Moving forward, we still have a few days left at the time of the recording and publishing of this video. We still have a few days left for the enemy design contest or showcase that I've got going on. So I'll have that linked in the description so that you can find that if you're interested and haven't heard about it, so you can check that out. Before I take this chapter too much further, I'm going to probably do the next video will probably be that enemy design showcase. So we'll look at your sprites and see how things are looking. And then once that's done, hopefully I'll be ready to start introducing our enemy, our more complex enemy with the finite state machine and the decision layer, and adding sensors for things like enemy vision and things like that. Okay, so that they have enemies that are smart and detect the player, and maybe they attack when they're close and things along those lines. Because obviously, if we were to add that into this script, then this script is in and of itself is going to get pretty big and unwieldy, and we don't really want that. Okay, so if you're new and you enjoy this, then please subscribe. It helps me grow, and that way you'll be able to see what's coming next. Obviously, I've got a backlog of a lot of stuff, but I'm also doing more new things in the future and trying to do a little bit more one-off videos right now. It's hard. I'm kind of busy, so as we all are. So it's hard to get out there and just make whatever I want, whenever I want, because that's just not a reality. But I hope you guys are liking it. Thank you for tuning in, and as always, we'll see you next time.